Hi, everybody. My name is Robert Hodges, and I'd like to welcome you to this talk called Hello Hydrate from Stream to ClickHouse with Apache Pulsar and Friends. My name is Robert Hodges. I'm CEO of Altinity. We're putting on the conference, and I'm your host at this talk today. Tim Spann works for StreamNative, and he is a developer advocate. I'll let him fill that out in his talk. And Tim, over to you.
Thank you. Yes, today we're talking on Pulsar. I'm Tim Spann. I'm over at StreamNative. I've put together what I call the flip stack, which is a combination of a couple of open source projects. It's Apache Flink, Apache Pulsar, sometimes Apache NiFi. Got all the relevant links in my slides, which we'll share out at the end of the talk. And if you have any questions, please feel free, put them in the chat and we'll get them as soon as we're done with the main part of the talk. StreamNative is kind of a new company, but it's founded by the original developers of Apache Pulsar. And we're using the open source plus hosting it in the cloud. And we're making a pretty interesting unified messaging and streaming platform. And it's got all those features you expect for today's real-time data, hybrid multi-cloud, geo-replication, being able to build microservices very easily, different streaming workloads, cloud native, so everything runs on Kubernetes if that's how you want to do it, and some features that are really helpful when you have either a lot of companies, maybe you're trying to put on one cluster, or different parts of your organization are very separate, multi-tenancies built into there, the ability to store all your messages forever, and being able to extend and connect to pretty much anything out there in the ecosystem. So multi-tenancy is very cool and very helpful. Scalability, you have to expect that at this point that you're not going to use something that only could do a couple of nodes, or maybe can only do a few 100,000 messages a second. This grows as big as you want. And if you look at some of the users out there, they're companies the size of Tencent. So we're talking, billions of events and not a problem. Geo-replication, because, who's just running in one availability zone or one cluster? Maybe you're in different parts of the world, different clouds, geo-replication between all of them without any heavy lifting. Unified messaging, and I'll show you what that means. It's kind of unique among the different messaging platforms. And as you expect, if you want your data to be secured and never lost, you could have pretty powerful data durability. That is something that can be turned off for certain topics if they don't need to be persistent. Maybe they just need to move through quickly and you don't have to worry about it. That is an option as well. Pulsar is a pretty big ecosystem, so we work with our friends like ClickHouse. We work with a lot of different data stores, whether they're a source or a sink, built-in ability to pull in Debezium and different change data capture, Pulsar IO to do all the different sources and sinks, supports for all the languages, so you don't have to use just one or two languages to be able to produce and consume messages. You could do things like Go, Java, C++, Python, Node.js, ton of different options out there, Kotlin, Scala, whatever you could think of. What's nice for storage is we have a very fast, low latency storage with Apache Bookkeeper, which is where we do our cloud native part, because our compute is in our Pulsar nodes and our storage is in our Bookkeeper nodes. And what's nice is how we say infinite. You could very easily configure the topics to decide, okay, after a certain amount of time or a certain amount of space, they just stream into object storage, whether it's S3 or GCS or Azure, and then it is available as if it's still on the topic. So you don't have to manually grab some messages from one place and then the rest from somewhere else. You could use your native way to consume those messages going back from the dawn of that data. And we can interactively query those with things like Presto, Trino, or Hive, and do stream and batch processing on that with Spark and Flink. Out of the box connectors there are very, very nice. And while events are in there, we've got our own function processing. So something happens to an event when that comes into a topic, you can execute automatically some code, and that can be in various of the languages we support, Java, Python, and some others. Now, when we said unified messaging, there is two types of thing you think of when you think of messaging. There could be the standard message queues, like you might be using SQS or MQ series or Rabbit. And, those work a certain way. Messages come in, it's often a work queue, things come into a queue and they come out, ordering usually isn't important. However, consumes them is not important. You just want to get data through the system, maybe executed, run processing as fast as possible. You do that. Well, we also support the other style of data streaming, where you want things like exactly once semantics, guaranteed ordering, all those sort of things like Kafka and Kinesis has, and Pulsar has that as well. So just depending on how you want to produce and consume your messages, you can choose either style, which makes it very powerful. We mentioned top of those couple, that tiered persistent storage is a very nice feature. As you expect, there's command line and REST interface to do whatever you need to do there. DevOps, grab data, consume data, do whatever. What's kind of interesting, those subscriptions are how we do that unified modeling. You pick how you're going to get your data. Support for other protocols, very cleanly, very easy to add them. It's designed from the beginning to support all different types of protocols. So certainly Pulsar for MQTT, so I could do IoT without having to have some other kind of brokers, AMQP for Rabbit, JMS, Kafka, lots of other ones are being added, very transparent to people using them. Once data's in, doesn't matter if it came in through MQTT or came in through WebSockets, I could pull it out however I want to. Standard pub scrub model there. Topics are a little different because I mentioned those tenants. So what's interesting is I could set up these tenants. These could be different companies, different lines of business, however you want to break it up. Under there, they have different namespaces and the topics are under there. So you can have millions of topics without an issue. It also makes it easier for you not have to worry about coming up with really long names for topics. So you can break them up under all these different segmentations, which is very helpful. I'm going to skip the subscription model. You'll get these slides. I think that can go pretty deep there, but there's different ways to get the data, and that really depends on your use case, which again makes for that flexibility. MQTT on Pulsar is just showing you how we add all these different protocols. It works as if it was the native one, so it's not something sitting outside of the cluster that's kind of a hack. It's really part of the native messaging structure. So it gives you all those features of all those types of messaging. Same with Kafka. Different sources, very easily to automatically configure. And I did that for ClickHouse. Simple YAML or JSON config, point to a topic, to a table, put that data into that topic, and it'll stream it into where you want to go. For my use case, it's ClickHouse, and I'll show you how I'm doing that. It is documented in the main Pulsar configuration, how to talk to ClickHouse. Very easy to do this. I set this up on Altinity Cloud because they gave me some space and it's really easy to do. So I set up a table and set up my little cluster there, and we'll go into that. I just wanted this in case network died on us. Didn't die on us, so everything is happy. Same kind of idea with Cloud for StreamNative. Support lots of different apps on there, pretty straightforward, runs in Kubernetes. So if you want to run it on premise, we could do that, or run it in any of the clouds. And along with Pulsar, we include Flink SQL as a way to do interactive queries and continuous queries on events as they come into topics. And again, I stored a couple of pages there just in case something crashed. E-commerce is a common use case, and we've got some pretty big e-commerce companies out there doing it. Because what's nice when you use Pulsar, people might be using a combination of messaging. Maybe when you're writing apps, you're using something like Rabbit or JMS. And then when you're doing your data services, it's Flink, it's Spark, maybe it's Kafka. With Pulsar, I could use one messaging system to support all these different clients and use cases, let you have one tool set and, one way to share data quickly. And if it needs to go to other kinds of storage, it can be done transparently, either from Flink or from Pulsar, pretty easy. This is a standard diagram for some of my apps. I've got devices sitting next to me gathering data, whether it's from sensors or cameras or wherever it may be, getting that data in. Sometimes they can only talk MQTT. That's fine. We'll just use a mop to get that data in. They only speak Kafka. They only speak WebSockets. Maybe they can speak native Pulsar. Doesn't matter. Maybe you need to go through a gateway like NiFi. Not a problem. Very easy to connect to Pulsar wherever you are in that process. Once something's in a topic, that event could go right to a sync. Like today, we go right to ClickHouse without anything in the way. Once it's in the topic, it's streamed out. And unless you want to set up some kind of bulk processing. And then again, you could have something like NiFi or your own programs pull that data out of Pulsar and do what other kind of apps that they might want to do. Now, not showing you 10 million slides because I don't think everyone just wants to see slides. I'm going to show you some demos on doing this with some of the tools. I've got all this documented in GitHub, so you can take a look at this afterwards and run it for yourself. So let's take a look and see where I have data starting. I have some data running on a device, everyone's favorite, the command line. This is a Xavier box. It's grabbing in cameras. It's doing some analytics on them. It's grabbing some device data there. And it's just pushing this into a couple of different topics and pushing some images somewhere else. So that data is just continuously coming in. So if I go to Altinity, I can run a query against the table that I'm populating and see when that data came in. For me, this is the current time on the East Coast here. This came in a few seconds ago. And I'm just doing a very simple query here, but just to show you as this data is coming into a table, pretty easy to see what's going on with it. This is my table here, and I can see I've already pulled in 500 records, and I started at the start of this. I just have data coming in every couple of seconds, not to overwhelm my 1 unit machine here. And it's just going to keep running. Pretty straightforward. What's nice with this is I didn't have to write anything. It is what we call a sync. And this just, you deploy this very simply. We go to the GitHub. I'll show you how to do it. So I created my table. So I have some place to store this data, standard data in a table there, not a big deal. But setting up a connector from Pulsar to ClickHouse is this easy. I pick my topic. Now, if you look at this topic within Pulsar, there's something a little different from maybe what you're used to in others. You get to decide, is this a persistent one or non-persistent as part of the name? This is that tenant. This is the default tenant that's created with any cluster. And this is namespace, again, the default namespace. And this is the name of my topic. So this bit of code, when I deploy it with either command line or through something like StreamNative, it's pretty straightforward. Just maps the topic to the table, and then your login information that you'll have there, and pretty straightforward. The Altinity Cloud gives you this connection pretty straightforward through JDBC, and it just runs it very straightforward. To deploy it is pretty straightforward. It's, if you want to do it in a DevOps process, you set up this command line, creates it in a couple of steps, and then you can get your status back, see where it is. About as easy as can be. If you want it easier, you could come over to the StreamNative Cloud, pick one of our sources, or create some new ones here in your tenant and namespace, set in some parameters and have it deployed for you. And then once you get your topic created, which you could just do in a simple click. Uh, when you send data in, there's a couple ways to do it. People tend to want a schema if it's something that's structured. Pulsar doesn't require structured data, but if I want to send it to a table, you're going to need that. So I can have JSON, I could have Avro, Protobuf, wherever you're setting up your schema, and you could build that schema, from the client side when you're building your producer, or you could build that schema in here. StreamNative and Pulsar have a built-in schema registry, pretty straightforward. And then here I could take a look at my topic and browse the topic without interrupting people consuming it, and can look at individual messages, see what the data is in there, look at different properties. I could add any properties I want to each message, same way that you can in Kafka. So it makes it pretty easy if you need to add your own metadata there, maybe link to an external schema, link to external analytics or anything you might have there. Pretty straightforward. If you needed some more connectors, we've got some of the preferred ones listed in our hub. So it'll show you how to use them, where to download them, how to get them, all those sort of things. Pretty straightforward, but gives you a nice way to do this. Now, another way to get data in is WebSockets. So I have a WebSocket app running here. This is just looking at energy data and just publishing it via WebSockets because that's, pretty neutral form. And what's nice here is if I send it with WebSockets, I can consume it with a regular Java client, a Python, with NiFi, with Pulsar, with Kafka, with MQTT, whichever protocol I pick and have enabled. Pretty straightforward. It also means that I can consume that very easily in a web page or mobile app. Now, like here, if I'm going to have it subscribed, it's subscribing to the first message that's configurable. So this is going to load every single message in that topic into my web page. Obviously, if I did fancier web UI, you could do something cool there, but just to show you the basics, and I have this in the GitHub, how you could just grab data from WebSockets. And once you're subscribed there, every time a new message comes in, it's going to get pushed out there. Very easy, not much work for you to do to get that data real time as it's put into the system. Pulsar will distribute it to anyone who's subscribed. Very easy. Now I can push data to Pulsar many ways. So you want to ingest data. Sometimes it's from IoT that can go directly into Pulsar. Sometimes it's through logs. Sometimes it's through, lots of different options there. I think one of the interesting ones is NiFi, another great open source project. Read your data from wherever it may be. There's a ton of different sources out there, whether it's databases, it's NoSQL stores, lots of different ways to get your data. Elastic. You get your data, do some configuration on it. Like here, I grabbed a zip file, converted it from RSS to JSON, and then I'm just going to push those records to Pulsar. Couldn't be easier. Got a little Pulsar connection pool, put my topics in here, and it'll just send the data for me. And it can do it in chunks or asynchronously, whatever makes more sense to you. My friend David built this processor a couple years ago, and we've just enhanced it. And it's pretty performant. Nice way to do that. Let's see if our WebSocket caught up. It's still a couple minutes behind. We'll have to make sure we're still sending current messages here. It should start getting the new ones, different time, and then it'll have all the messages, in one place until I guess I overload my browser by sending too many messages there. But pretty straightforward to do. So in one of my ones, I'm sending data to MQTT. Again, I don't have to consume it as MQTT. Once it was pushed into a broker it assumed was an MQTT broker, I can consume it out as native Pulsar, and it doesn't matter. whatever you're familiar with, whatever your favorite consumer is. I can read it as if it was Kafka, if it was MQTT, and just pointing to that same cluster. Don't have to change anything other than, there's usually different ports for different services. Or, if you want to have different domains or however you want to do that through maybe a proxy or a router, whatever makes sense for you there. But that's just an example of how easy it is to connect these things without having to do a lot of heavy lifting. I don't know if we have any questions yet, but we have a couple of minutes left. So if we have any questions, I'll go into it. Otherwise, I'll go through a little bit more, couple of slides I have left, and maybe browse around the demo some more and show you some different pieces there.
Hey, Tim, this is Robert.
Sure.
Absolutely amazing demo. Thank you so much for this talk. I had a question for you. You showed a screen where you have just a bunch of adapters that you were, for different sources and sinks. What's the effort to exactly this? So are these all open source? That's the first question.
Yes.
Cool. And what's the effort to develop one of these adapters and get it put in the hub?
It is pretty minimal. There's actually a talk at the last Pulsar Summit by a dev advocate from Elasticsearch showing you how to do it, which was pretty nice. There's a template on StreamNative's GitHub that makes it even easier. You just extend that and build it. And once it's built, just tell the community, we'll get it tested, and then we'll add it to a link here. If you're someone who's already a friend of us, it makes it quicker because, you're like, hey, we're going to put this in. You want to test it? Well, sure. But I mean, there's a very active community in Pulsar. Whether you go to our, let me go into here, whether you go to our Slack channel or subscribe to the monthly thing or a part of the Apache project, a lot of people out there. We're definitely interested in more connectors. We already have a JDBC connector for ClickHouse that's in the documentation. But if you wanted to build one that used maybe some other mechanism or was a dedicated type of sync for that had some extra stuff in it, you could definitely add that one to it, or anyone else out there with different things you want to connect. And it's not just connectors, it's source and sync, but we also have things like other protocols, like we mentioned for AMQP and MOP, but also things like offloaders. So these can be set up as part of that tiered storage. So you add one, maybe you have your own cloud. We have some clouds that aren't the main three that are adding some connectors as well, things like Alibaba. If you have your own thing that's kind of like a file system and you want to write an offloader, again, that part's open. Protocol handlers are open. If you have components you want to add that, do processing, we're always open to adding those as well. Different ones for logging, connection to different monitoring tools, whatever makes sense. It's all open. This is about the most open source project out there. Community's very welcoming of new people, and there's lots of different room for you to add, connectors if you're interested.
Great. I'd like to invite people to pose questions if anybody has them. I do have a couple more. The Kafka the APIs that you have are really interesting.
Yes.
And what's the difference between, sort of using your implementation of Kafka versus Kafka itself? Is there anything that people would really notice? In other words, what's the level of compliance?
To my knowledge, it's complete. We don't have KSQL DB in there because we have Flink SQL and we have Trino. We don't have K-streams, but we have, Pulsar functions. But from someone writing a producer or consumer, you could use any of the native libraries.
Okay.
So from that part, it doesn't, it looks the same. It's we can follow those same semantics of how they do things, even if it's exactly once, how they do ordering. So
Right.
it could look like a regular topic. Obviously, things like tenants and namespaces don't make sense to Kafka. So,
Mhm.
you can use those within the Kafka producers and consumers, but it might be confusing to people who are using Kafka.
Mhm.
And then, if you want to keep it separate, you could keep it separate. If you start mix and matching, have Pulsar consume the Kafka producer, that might be confusing to the Kafka people. But,
Mhm.
again, the comment is no one's going to have just one thing in your enterprise. You've been running things for a very long time. You're going to have lots of different things. This is nice to be able to integrate all those messages into one place. Maybe the new ones, you're right, Pulsar, and then, it may take you years to get rid of other messaging systems. But here's a great way to have a gateway or a future path for that. Point your existing apps to Pulsar using these different protocols. And when you're ready to move over, you can give it a try. Oh, this one is interesting. When is it better to use Pulsar or NiFi? That is a good one. Now, NiFi, which if you've seen me talk, I've been talking about NiFi for over 5 years. NiFi is great. NiFi is not a messaging queue. It's not a place to put data. It does processing. You read stuff, process it, send it somewhere, but it isn't a queue. It isn't durable storage for it. People tend to put NiFi together with Pulsar or Kafka. So you have that durable data durability there and the ability to other consumers have it. NiFi is great in cases that aren't good for Pulsar, thing like image processing. Don't really want to do that with Pulsar. Pulsar is the place where I put data in there from any place, send it somewhere else. People share it, run things on it, and have it durable, act as a durable place for your data to exchange it between any different clients, different applications. They work well together. It's the same with Flink. You can't do everything in one place. NiFi has something similar. Again, sources and sinks, but NiFi tends to operate on a different level. It's let me read some files, do some processing on them, convert them, and then store them somewhere. These queues within NiFi, no one's thinking, let me store 1 billion records there for the next 10 years. That's not the process. This is a cache. So, I mean, those two together, very nice, because NiFi can do that Swiss Army knife of easily and graphically getting some data, converting it, and then getting it into Pulsar so I can have a Spark job run it, or I can have it automatically streamed to ClickHouse. Things like that are where they fit together really nice.
Cool. Looks like we're at the edge of the talk. Are there any further questions from the crowd? All right, I don't see questions coming up. Tim, thank you so much for discussing Apache Pulsar. That's the first time I think I've really seen a demo of it. And on behalf of your audience, thanks again. And thanks to the audience as well. We will see you in later talks in the conference. Talk to you soon. Bye.
Thanks for coming.